Python is, by some measures, the most popular programming language in the world. Today we'll talk about its most important characteristics and some niches that it fills. Welcome to Kopek Explains Software, the podcast where we make computing intelligible. Today we're going to be talking about Python. Rebecca, where should we start?
Let's start at the beginning. When was Python developed and by who?
Python is actually an over 30-year-old language. It was developed in 1991 by Guido van Rossum.
And who's leading it now?
So Guido led the development of Python all the way until 2018 as the BDFL, the Benevolent Dictator for Life. And several different open source languages actually still have an individual who makes all of the final technical decisions. And Guido served in that role all the way until just a few years ago. Starting in 2018, he turned over the keys to a 5-person steering council who was elected and now gets to make the final decisions in the language. The language and its ecosystem is sponsored by the Python Software Foundation, a nonprofit that was set up in 2001 to promote the language and continue its advancement.
And Van Rossum started this language or built it as a successor to another programming language, ABC, is that right?
Yes, and when he first developed the language in the 1990s, it was seen as a scripting language. It's still oftentimes seen as a scripting language, but in many ways, it's grown beyond that.
So how is it used today?
There are about 6 different niches that I want to point out where Python really dominates. 3 of them are kind of related. The areas of data science, scientific computing, and machine learning, which all have some overlap with one another, are all areas where Python really has come to dominate. However, it's also used for back-end web development. 2 popular back-end web development frameworks are Flask and Django, both of which have been around for over a decade. Python is also used a lot in education. A lot of universities have adopted it as the language used in their introductory programming courses. And we'll talk in a few minutes about some aspects of the language that make it appealing as a language to first learn programming in. And it's still used as a scripting language. So sometimes there are just some tasks that need to be automated, whether that be by system administrators or web developers or as a component of a larger system. For example, I know some earlier versions of the Civilization game franchise used Python as a scripting language, and I know some games today that are still AAA, huge games, use Python to trigger sequences of actions when certain events happen in the games. So Python has a lot of different niches that it has blossomed in, but I should also say that it is also a general purpose programming language. It can be used for many other things. Those are just the areas where it's particularly prominent.
What are some of the technical characteristics of Python?
A lot of people call Python a multi-paradigm language, meaning that you can program it in multiple different styles and ways. For example, you can program it in an imperative style, you can program it in an object-oriented style, you can program it in a functional style. The reality is, in my experience, that most Python code is object-oriented that's of any significant size. You will see Python programmed in more of a plain imperative style or in more of a functional style, but it's not as common as using it in an object-oriented style. There are multiple different implementations of Python. The reference implementation developed by the Python Software Foundation is known as CPython. It's called CPython because it's implemented in the C programming language. But just because it's implemented in C doesn't mean that it's fast. The main implementation of Python is actually a bytecode interpreter. So your code is first compiled to bytecode, and then the bytecode interpreter looks at each of the bytecode instructions one at a time as the program is running. There are alternative implementations of Python, the most popular of which is called PyPy, P-Y-P-Y, which actually has a just-in-time compiler, and it can outcompete CPython in many benchmarks, and in a lot of real-world use cases as well. Python is dynamically typed, meaning that when your program is written, you don't need to declare the types of your function signatures or your variables, And actually, at the time your program is converted into Python bytecode, types are not even largely looked at, and at runtime is when types are really determined. It's also duck typed, which means that if an object implements a certain behavior, if it quote-unquote quacks like a duck, it can be treated like an object of a certain type just by having that behavior without even having been declared to be of that type. So Python is a very dynamic language. More recently, there has been the concept of gradual typing added to the language. That's the idea that you can actually put in some types. In Python, they're called type annotations at the time that you're writing your code. So you can explicitly say, for example, that a certain variable is of a certain type. But the current mainline implementations of Python actually ignore those type annotations at runtime, and they can more be used by third-party tools for type checking. It's possible that in future versions of Python, those type annotations will be more explicitly taken advantage of, perhaps for things like performance or type checking. Overall, it's just a very dynamic language. And I should also mention, as you might expect for a modern scripting language, that it's garbage collected. So when you write Python, you really don't need to worry about memory. Finally, I would just add that it has a big standard library that's sometimes called being batteries included. Everything you can imagine is in the standard library. While Python has a really robust library ecosystem, you often don't need to reach for it for a lot of your program.
So it sounds like it has some really interesting technical features, but what are some of the features that differentiate it from other programming languages?
I'd say the thing that usually attracts people to Python in the first place is its beautiful syntax. Python code sometimes reads like pseudocode from a textbook. There's a few really key decisions that were made during its development about how its syntax is structured and the philosophy behind its syntax that I think have resonated throughout the decades that it's existed. One of which was the decision to use whitespace as a way of explicitly structuring a program. So when you define a new function in Python, you actually, on the next line after the Python function signature, indent your code a little bit, and that indicates this is the body of the function. Now, you're supposed to do that anyway in most programming languages if you're following good style practices, but in Python it's required. And so it forces everyone to write in a readable way. And in fact, that's how the language implementation actually can see what code is part of what function or what code is part of what while loop, etc. If you think about a language like C or Java, you're going to have curly braces, but the indentation doesn't really matter within those curly braces for a particular function or loop or other structure. And so while you're supposed to indent, it's not actually forced on you. Whereas in Python, by explicitly using whitespace and indentation, you force the programs to be readable to a certain extent. Another great thing about Python's syntax is how succinct it tends to be. And there are certain constructs in the language that make it particularly succinct, like list comprehensions, but it's also just a very high-level language, and it has a really rich standard library. So you tend to be able to do something in one line of Python that'll take you a few lines of another programming language. The other really attractive thing about Python is something I mentioned earlier, which is its really rich library ecosystem. There are some incredible libraries that are very, very popular in the Python world. Things like TensorFlow for machine learning, or Django for back-end web development. These libraries are really robust and have fantastic developer communities, and perhaps they more than anything have propelled the language. People want to use these fantastic libraries, and to use them, you have to write in Python. So I would say its beautiful syntax and its library ecosystem are the two things that have most propelled Python forward.
But it's not all sunshine and rainbows. What are some of the critiques or challenges with Python?
The biggest challenge when working in Python is its performance. We spoke earlier about how the main implementation of Python, CPython, is a bytecode interpreter. As an interpreted language, it can be an order of magnitude slower than popular compiled languages like C or C++. It's not unusual for a pure Python benchmark to find that Python is up to 50 times slower than the equivalent program in C or C++. So if you're writing something that's computationally intensive, you can't really do it in pure Python. To make up for this, Python has facilities for writing extensions to your program in C, and there's also alternative ways of doing that like Cython. However, that's quite cumbersome. That means you're writing some of your program in Python, some of it in C, and then you have some kind of bridge between the Python and the C. But you have to go through this cumbersome process if you want real performance. The good news is that a lot of the popular libraries in Python that are used for computationally intensive tasks, for example, NumPy, which is used for numerical computing, are already written as C extensions. So they already are quite performant. And you're kind of writing glue code in Python that's using these performant libraries that are written as C extensions. Even some of the alternative implementations like PyPy, while more performant than CPython, are still not on the level of other popular programming languages. So Python has a real performance problem. And another aspect of that is what's called the global interpreter lock, or the GIL, which has some limitations that have to do with concurrency that I think go a little bit beyond the scope of our show today. But that's another big criticism of Python, is some of those limitations that come with the GIL. Another criticism of Python is that it's simply too dynamic a language. It's so dynamic that it can actually be prone to certain kinds of programmer errors. We spoke earlier about gradual typing. That's one facility that tries to remove some of that dynamicism, at least by forcing you to declare types before your program runs that can be checked to reduce some type errors. So people are trying to find ways around some of its incredible dynamicism. And then one that's kind of history now, but was a big criticism of Python, was the transition from version 2 to version 3 of the language. Python 2 came out around the year 2000, and it only was ended officially in terms of getting patches in 2020. But Python 3 came out in 2008. So there were 12 years where there were two different mainline versions of the language that were being distributed. There was a lot of trouble getting people to move from Python 2 to Python 3. Python 3 was largely syntactically compatible with Python 2, but not 100%. And so a lot of programs did actually have to have modifications to run in Python 3. And there just didn't seem, at least in early versions of Python 3, to be a compelling enough narrative about why people should upgrade to get people to actually port their code from Python 2 to Python 3. And so they got into this really difficult situation where some people were using Python 2 and some people were using Python 3. And that led to a split in the ecosystem. Today, that's been resolved, and all new Python development happens on Python 3, and Python 2 is no longer supported by the Python Software Foundation. But that said, it was a really difficult transition, and it made a lot of people very upset.
So, who should learn Python?
Well, we talked about how it's used in education, and Python really is a great first language. I like how its beautiful syntax really resembles a lot of code that you might see as pseudocode in a textbook. So it makes it really easy to translate as you're learning something that might actually be written out in pseudocode into Python. And I also love how succinct it is, because it means that you can get more done more quickly when you're first learning. Also thanks to that big standard library. So I think it's a great educational language, great language for people who are first learning programming. Of course, if you work in data science, machine learning, or scientific computing, it has become basically the de facto standard language in those communities. So if you plan on working in those areas, or you already do and you know a different language, it's probably worth learning. Especially if there's some particular library like TensorFlow that we talked about earlier that you want to use, and Python is really the native language of that library. And Python is just so ubiquitous today. By many measures, it's the most popular programming language in the world. For example, IEEE did a survey last year where they found that it had come to be the #1 language. So I think basically everyone who works in software development today, it's not a bad idea to at least be familiar with it. That said, there are some areas where it's really not used and not going to be that helpful to you. For example, Python is really not used at all in mobile app development. So nobody's building apps for iOS or Android in Python. While there are some ways to do that, it's extremely uncommon. There are some people who it might not be worth your time, but for most people in software, it's a pretty useful skill set to have. Thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you in 2 weeks.
Bye.